everybody, welcome to my YouTube channel Easy Mathematics. Today it is the Independence Day. So I wish all of you a very happy Independence Day. This is the situation where we all are at home and I wish that as soon as possible we should be independent from this COVID pandemic also. Okay, so now come back to this video. So today's video is about the geometric progression. So what is geometric progression? That we have discussed in our previous video lecture, but still I am again giving you one example that what is geometric progression. So for that, I have a paper. So just look, I have a paper and I have folded it once. So if this fold is happened, for one fold I get the equal parts of this paper. So after that, if I fold it once more, then what we will find out by this folding, just look, we will get 4 separate portions. Just by 2 fold we will get 4. Now after that again if we fold this paper, then what happens? Just after folding you will find out that here total after 4 we will get 8 separate parts. 1, 2, 3, 4, 5, 6, 7, 8. So by 3 fold we will get 8 portions. So in this way, when we fold a paper, then for each fold we will find out that the number of separation or the number of portions will be double the previous portion. So anyways, this way when the parts are increasing, then it is under the GP or the geometric progression. Now what is the definition for GP? A series in which ratio between any two consecutive terms is constant. So what we will say? Let this one A1, A2, A3, AN is a GP series. So here definitely all these terms should not be 0. And if we take any two consecutive term and their ratio if we find out, then this ratio is a constant value. Remember, any two term we may choose, always we will find out this ratio is a constant. Then the series is called a GP series. That means the same series we can write in this format. If we say A1 is the A, this is our first term, then common ratio is R, then the second term definitely we can say the first term into R, the common ratio, so that AR is the second term. Similarly, AR square should be the third term, and likewise if we proceed, then we will find out our entire GP by only two expressions, that is A and R is required to express a GP entirely. So that here A and R, A is the first term, R is the common ratio. Then in general, the nth term we can say A into R to the power n minus 1. Why it is n minus 1? Because just look, first term here R to the power 0. Second term R to the power 1. Third term R to the power 2. So nth term means R to the power n minus 1. So this is our nth term. Now the summation. Summation means if we add all those terms, then what will be the summation of the series that now we are going to consider. So summation should be expressed by Sn. So Sn should be the addition of all those terms. Here we consider the summation of n terms up to. Here it may be the infinite number of terms may exist. But we consider right now here it is the nth term up to. So now if we just add all this up, after that we just multiply. That means our requirement is to find out the value of this one. So this is our entire expression. So how to find out or to simplify a simplified form of a Sn? For that what we will do? But simply we multiply this entire Sn by R. After this multiplication we will find out R of Sn is equals to A into R, then AR square, AR cube. In this way it will continue up to AR to the power n. So that I have written, and I just shifted one point. That means AR, the first term, we write in just beneath the AR. So after writing this one, we just subtract these two. So if we subtract these two, then what we will find out here? If we shall take common Sn, then it becomes 1 minus R into Sn. Now just look, here all are the subtraction. So that this one same term, so cancel out. These two same term cancel out. So in this way all the terms cancel out except this A, and here this is AR to the power n. So it will be A minus AR to the power n. Now if we take A common from here, then we will find out A into 1 minus R to the power n. So Sn is equals to A 1 minus r to the power n whole divided by 1 minus r, provided r should not be equals to 1. Now one thing is here, if your r value is greater than 1 or less than 1, greater than 1 or less than 1, depending upon that, your formula either be this one or this one. Definitely, if your r value is less than 1, then this formula we will choose. And if your r value is greater than 1, then we should write this formula. Okay. So now, hence for the different r values, we can have the different values of Fn. So how this Sn will change for the different r, that we will look now. So here the given GP, we know that Sn should be a plus ar plus ar square plus, in this way it is up to nth term. Now Sn is this one we have calculated for a not equals to 1. Now what happened first of all, if r is equals to 1. So if we substitute here r is equals to 1, then what we will find out? This is a, then plus a, again plus a, again plus a. So in this way all those terms are a. How many terms are there? Total n number of terms. So when r is equals to 1, then the total sum Sn is equals to definitely n times a, means na. So that is for r is equals to 1. When r is equals to exactly minus 1, then what happens? So when r is equals to minus 1, that time if we substitute here, then we will find out it is alternative plus minus we will find out. So now, depending upon the value of n, that means n is even or odd, depending upon that, we will find out this value is either 0 or a, because two consecutive terms are plus minus, then that becomes cancel out. If there are n is odd, then one a will remaining and we will find out this summation is a. And if n is even, then the total number of even term and total number of odd term, that means first total number of plus 1 and total number of minus 1 will same, so that will cancel out, and finally we will get the value 0 if n is even. So when r is equals to minus 1 and it is even, then the Sn is 0, and when r is equals to minus 1 and n is odd, then Sn is equals to a. This is for the finite case. The number of terms are finite, that means total n number of terms are there. What happens if our number of terms are infinite? That means n tends to infinity. If n tends to infinity, then what happens to this? So here the first term is known, common ratio is known, but the last term is not known because it is going towards infinity. So n going towards infinity means what? Here if we substitute r to the power n, here if r value is less than 1, that means r value less than 1, but definitely it is greater than 0. Then what happened? R may be half or like this value. So its power is infinity. So that definitely something divided by infinity of this type. So anything divided by infinity is 0, that we know. So if we just substitute here n tends to infinity, then here r to the power n tends to infinity. R to the power n tends to 0 then. So that finally we left with a divided by 1 minus r. So that part. So r value should lies in between, in that case minus 1 to plus 1, that you should remember, that you should ensure. Okay. So now if it is so, what happens when r value is greater than 1 and r value is less than minus 1? In between we get the value. But when r is greater than 1, that time what happens? R, suppose it is 2, 3, 4 anything. So if it is so, then 2, 3, 4 r value and n is infinity. So anything to the power infinity is infinity. When it is not a fraction, that means when the value is not less than 1, that means it is either 2, that is more than 1 actually. So if we consider 2, then 2 to the power infinity is infinity. So that when r is greater than 1 and n tends to infinity, then Sn goes to plus infinity. Likewise, when r is less than minus 1, for the same reason, it is going towards minus infinity. So for the different r values, we will have the different Sn depending upon the situation. So let us observe this one with an example. So the example, the first term of the infinite GP series is 1 and any term is equal to the sum of all succeeding terms. Find the series. So what is given? That if an is the nth term, then this one is the summation of all the preceding terms. That means an plus 1, an plus 2 in this way. If you add all those, then this summation is your an. We know that an means a r to the power n minus 1. So that if we just substitute all these terms corresponding in this first term and the common ratio, then this one is the expression. Now from this one we can take a r to the power n common. After taking this common, the rest is 1 plus r square in this way. So this one is an infinite GP series with first term as 1 and the common ratio as r. We know as this is the infinite GP series with 1 as a first term and r as a common ratio, so its value is a divided by 1 minus r, that is 1 divided by 1 minus r. So that we can write this one as 1. For this one we write 1 divided by 1 minus r. Now both side from, if we cancel a and r to the power n minus 1, then it will be left as 1 is equals to only r from here. So 1 is equals to r into 1 by 1 minus r. So that will implies on simplification r is equals to half. Hence the required sequence is first term is 1, second term is a into r, that is half, third term is a r square, that is 1 by 2 square. In this way it will continue. So this is the our required GP series. Now few properties of the GP series. Some important properties are there for the GP series. So the first property is the product of the terms equidistant from the beginning and end is constant and is equal to the product of the first and the last term. So what it says, that a infinite GP series, that means a finite GP series with n number of terms is, let it is a r square in this way. So the last term is a r to the power n minus 1. Now the first term definitely is a and the last term for this series is a into r to the power n minus 1. Now if we multiply these two, that means a1 into an, then what we will find out, it is a and it is a into r to the power n minus 1. If we multiply, we will get a square into r to the power n minus 1. Now if we multiply the second term, that means this one, it is our a2, and from last second one, that is this is our a n minus 1. So if we multiply these two, then its value is ar for a2 and ar to the power n minus 2 for a n minus 1. So if we multiply these two, then we will find out a square r to the power n minus 1. Just look, both are same. Now similarly, if we multiply the third term from the first and the third term from the last, we will again the same value. And in this way, if we proceed, then we can say that a1 an is equals to a2 an minus 1. In this way, all those terms are equals to the first term and the last term. So hence the proof. Now it is the second property. If every term of a GP is multiplied or divided by the sum of non-zero quantity, the resulting progression is a GP with same common ratio. So again let us take the example as ar square up to ar to the power n minus 1 is an finite GP series with n number of terms. Now let us multiply this series by c, any constant. So after multiplication we will get this one. So definitely here CA is our first term and the common ratio is same R, no change is there. Likewise, if we divide the given series by a term D, so after that division, what we will find out, it is A by D, AR by D in this way. So here the first term we can say it is A by D and the common ratio is definitely R. So we get the property. Now the next property is, if each term of a GP be raised to the same power k, then resulting series is also a GP with common ratio r to the power k. So what is here? So if this one is the GP series and all those terms if taken power as k, that means a to the power k, ar to the power k, in this way all those terms are taken in the power k. Then what happens? If we simplify, then we will find out here it is a to the power k, a to the power k, r to the power k. Here a to the power k, r to the power 2k in this way. So the common ratio, if we want to find out here, then any two term we consider and their ratio if we consider, then we will find out it is r to the power k. So which is the property. So one more property is, if a1, a2, a3 in this way infinite number of terms, and B1, B2, B3. In this way, this is again one more series, B2 GP series with common ratio R1 and R2 respectively. Then if we multiply the respective terms, then we will find out this series. This is A1 B1 into A1 B1, A2 B2, A3 B3 in this way. And if we divide them, that means A1 by B1, A2 by B2, A3 by B3. In this way, these two series which we will find out, these are also a GP series with the common ratio R1, R2 for this one and R1 by R2 for this series. So how to prove this one? So for this also, what we will do, the sequence is this one where A is taken as the first term and R1 as the common ratio. So the sequence becomes this one. Similarly, for the second one, if B is the first term and R2 is the common ratio, then the sequence we will find out this one. Now, if we multiply the corresponding first terms, then the sequence becomes this one. So it is AB, R1, R2 in this way. So definitely here the first term is AB and the common ratio is R1, R2. Likewise, if we just divide them, then what we will find out as the common ratio? So the first term, first of all, it is A by B and the common ratio is definitely R1 by R2. One more property for, we can say, if A1, A2, A3 in this way a GP series is given of positive terms, then log of A1, log A2, log A3, this one will be a AP series and conversely. That means this one is a GP series. And if we take the log of these terms, then this becomes a AP series. Likewise, if the log series is given, that one is an AP series, then its anti-log series is a GP series. That always will happen. So how to find out? So for that, if this one is the general terms of a series, then of a sequence, GP sequence, then its terms we can write AR square in this way. Now if we take log on all those terms, then what we will find out? For the first term, log A1 is log A. Now for the second term, log A2 is equals to log AR, that we can write log A plus log R. Likewise, log A3 is log AR square, which we can write log A plus 2 into log R. In this way, we can write down the last term as log AN, which is equals to log AR to the power n minus 1, which we can write down on simplification log A plus n minus 1 into log R. So this sequence becomes this one. So log A plus log R, log A plus 2 log R. In this way, this one becomes your now the new sequence. Here the first term, if we say log A, then the common difference is definitely, if we subtract these two, then it is log R. And you will find out that this is the first term and this is the common difference in between any two consecutive terms. Hence we can say this one is an AP series. One more property for, we can say, if the terms of a given GP series are chosen at regular intervals, then the new sequence which you will find out, that is also in GP. What does it mean? If this one is your given sequence and here from we just choose few terms in a regular interval. That means if we choose the first, after that if we skip the second and take the third one, then always we just skip this after that term and then choose the next one. That means if I choose this one, this one, this one in this way, otherwise if I choose this one with that this one, that means after two skipping. So in this way, if I choose, that means here consider the first term, third term, fifth term I have chosen. So if I choose in this way, then the new sequence which will form, that becomes AR square, AR to the power 4 in this way. So that one is also a GP, and depending upon your skipping, that means after how long you are considering the second term. After first term, how many terms you skip, depending upon that your common ratio will change. So here as I skip the only one term after the each term, then the common ratio is R square. In this way, any term you can consider. That means from a GP you can construct so many GPs. So now for supporting to this one, let us have an example. So in this example, it is given that if there exists a GP containing 27, 8 and 12 as three of its terms, definitely these terms are not necessarily consecutive terms. Then how many progressions are possible? With these three terms containing, how many GPs can be possible to construct? So initially, let us consider 8 is our first term. So it is A1. And the 12 we can say the mth term and 27 we say nth term. We don't know which term is this one. So That means mth term is 12, so that we can write 12 is equals to 8, this is the first term, into r to the power m minus 1. Similarly, 27 is equals to, we can say 8 into r to the power of n minus 1, because it is the nth term. Now, if we take the ratio between these two, that means 27 by 12, then it becomes r to the power n minus m. So, here that will imply, if we simplify, then what we will find out, it is 3 by 2. That means it is actually 9 by 4 after simplification. Then its whole square we can write in this way. So that we can say again that 12 by 8. That means if we take the ratio between this term and this term, then it is 12 by 8. So 12 by 8 should be r to the power m minus 1. So that will imply 3 by 2 is equals to r to the power m minus 1. Hence, from these two, what we will get? It is r to the power m minus 1 its whole square. If we consider, then that one should be equals to r to the power n minus m. So if we simplify, then it becomes, actually we just equate the powers because both are r. So here the power is what? 2m minus 2 and it is n minus m. And on simplification, it will gives us m by 1 is equals to n plus 2 by 3 is equals to k. That will imply m should be k and n should be 3k minus 2. So now for the different values of k. So k can be taken as 2, 3, 4. Definitely k can't we take as 1 because then it becomes the negative. So if we consider k values as 2, 3, 4 likewise, then we get the distinct values of m and n. Hence, there we can form the infinite number of GPs where these three terms are included in that GP. So that is our answer. So here the different properties we learned, and we come to know that what is GP, how to solve the different problems related to GP. Now one question for you, that is the do by yourself question, and the question is the first two terms of a GP add up to 12. The sum of the third and the fourth terms is 48. If the terms of the GP are alternatively positive and negative, then the first term is what out of these four options? So that is your question. You just solve the question and answer the for this question in the comment box. I am waiting for your answer. I hope you like this video. This is our GP. Today is the Independence Day. So once again, happy Independence Day to you all. Have a nice day. Stay safe, stay healthy. Thank you.